Okay, so as in the last video, we have completed MCQs from the KIPS work of atomic structure, and we have discussed atomic structure chapter in very detail. Alright, we initially completed our stoichiometry, which was chapter number 1. Then we completed atomic structure in very detail with all types of MCQs, right? We solved MCQs from Sindh board book, Punjab board book, KPK board book, Federal board book, and we have solved MCQs from ECAT book, KIPS book, and OETP, the nurse past papers guidebook as well. Alright, so after solving those all, now we are with our new chapter, which is chapter number 3, theories of covalent bond, right? So we will be discussing each and everything about the covalent bond here and the theories of covalent bond, right? But before moving towards our main topic, we should be known that what is chemical bonding, what are the types of chemical bonding, what are their subtypes, right? We should be known about each and everything, and why do we form a chemical bond, right? So we should be known about each and everything. That's why our today's lesson would be all about the introduction of the chemical bonding. What is chemical bonding, what is their types, what are their subtypes, why do we form chemical bonding, right? So let's discuss what is chemical bonding, as this chapter is very important, right? Chemical bonding. See, chemical bonding is nothing, but it is sometimes a force between the two atoms, right? Because there are some types of chemical bonding. If we'll be talking about ionic bond, there will be only a force between the two atoms, right? Which will gonna held those two atoms together, and that force would be known as electrostatic force. In the form of ionic bond, we have a force which holds two atoms together, which means chemical bonding is nothing but it is the force between the two atoms, right? But in some covalent, in some types of covalent, not covalent, however, the chemical bonding is like covalent bond, right? There is a proper attraction between the two atoms. They share their electron with each other in the covalent bond, so that is known as bonding, right? So sometimes the chemical bonding is a force between the two atoms, sometimes it is actual a bonding between the two atoms, right? Sometimes it is the force between two atoms, right? For example, ionic, right? NaCl. Here just transfer electron is transferred from one to another, right? It loses an electron and it gains an electron, but there is a force between them. There is not even a bond between them, right? They do not share the electron. There is a complete transformation of electron to from one to another, right? Which forms a force here between these. And we don't actually write like this, because as this is a force, so we do write like this. So this is actually a force between them, not a bond, however force, which is known as electrostatic force. Electrostatic force, which we have detailed in very detail in the atomic structure as well, right? Which is equal to what? F E is equal to K Q1 Q2 over R square, right? Or you can write ZE square upon 4 pi epsilon naught R square. Epsilon naught R square. Or you can write K Q1 Q2 over R square. Both are equal, right? So sometimes it is a force between two atoms. For example, in the ionic bond, there is just a force between two atoms which forms a bond, right? And that force is known as electrostatic force of repulsion, and that is equal to Z square upon 4 pi epsilon naught R square, or K Q1 Q2 over R square, right? Now we are going to see the actual bonding, right? Actual bonding. So sometimes there is a bonding between two atoms. Two atoms, right? For example, we have a covalent bond, right? For example, H2O. H2O. What's the structure of H2O? There are total electrons 2 and its valence electrons are 6. So 6 and 2 are basically 8 electrons. Let's make Lewis-Dot structure. I'll be explaining each and everything in very detail. Lewis-Dot structure, we're gonna have the entire video on it with all the tricks, right? So here we have O, one bond with H here, one bond again with H here, right? So there are two bonds, 2 twos are 4 electrons, again 4 electrons are remaining. So 1 2 3 4. Let's count the electrons. 1 2 3 4 5 6 7 8. Oxygens is complete, and here 1 2 complete, 1 2 complete. So this is a H2O structure, right? Here basically they share the electron, right? Here they share the electron. Oxygen shares their electron with the hydrogen, right? Hydrogen shares their electron with the oxygen. So there is a basically complete bonding between this. So this bonding is basically known as chemical bonding. The force of attraction between two atoms, which was known as electrostatic force, was also a bonding. However, here we have sharing of electron. Sharing of electron is also a bonding. Sharing of electrons is also a bonding. Sharing of electron is also a bonding, right? So we have read what is chemical bonding. Chemical bonding is sometimes a force between the two atoms, which is known as electrostatic force, which is equal to Ze square upon 4 pi epsilon naught r square, or kq1 q2 over r square, right? And sometimes it is actual a bonding between two atoms, right? For example, covalent bond, H2O, there is actually a bond between them since there is happening of sharing of electrons, so it forms a bond between it, right? So that's why sometimes force is also a chemical bonding between two atoms. Bonding, the actual bonding, the sharing of electron, is also a chemical bonding in the compounds, right? So now the main question is, why do we form chemical bonding? Why? What's the reason of formation of the chemical bonding, right? Reason of formation of chemical bonding. Why do we form it, right? So initially when people research, when scientists researched it, why do we form chemical bonding? They got to know that we need to complete our octet rule in order to make our compounds stable, right? We need to achieve octet rule, octet rule, right? We need to achieve the octet rule in order to make our compound stable, or noble gas configuration, noble gas configuration, right? In order to make our compound stable, right? Which means chemical bonding main reason is stability. To achieve stability, right? Achieving of the stability, right? Then the scientists come, and now the main reason of formation of chemical bonding is, now For example, I'm explaining you with an example which is very 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 good example, right? For example, I have nucleus here, this first shell, this second shell, and this is third shell, right? Here I have an electron, here I have an electron, here I have an electron as well. We have discussed each and everything here in the atomic structure as well. This electron or this shell will be having lower energy. This is minus 13.6 electron volt, right? Then here we will have more lower energy, minus 3.4 electron volt, which is greater than minus 13.6, right? Then we have minus 1.85 electron volt, right, which is more greater than minus 3.4 electron volt. So if I do ask you, minus 13.6 is less than minus 3.4 is less than minus 1.84, which means minus 1.84 is the greater one. It is the greater one, highest energy, right? Highest energy, which means this electron isn't stable. This has highest energy. To make itself stable, it has to lower its energy, right, to come to the again back to the shells, right? It has to lower down its energy in order to make itself stable, right? So now scientist says, in order to make or achieve stability, we need to lower down the energy of the system, right? If I would have lowered down the electrons energy, it would have become stable, right? So if I'll gonna lower down the energy of the system, it would gonna be stable, right? Here we have one more example. If I have one body here placed, right, and if I have another body placed here, what would be more stable, right? Its potential energy is higher, right? Potential energy higher, right? And its potential energy is lower. So which is more stable? Of course, this is more stable as compared to this. This isn't stable, right? So we need to lower down the energy of the system in order to make or achieve the stability. So the main reason of chemical bonding is to achieve the stability by lowering down the potential energy of the system. This is the main reason of formation of chemical bonding. So in today's video, we have gone through basic introduction of the chemical bonding, what it is, right, and why do we form it, right? In next video, we're gonna look into the types of chemical bonding and their subtypes too. So this was all for today.